How are you? So we are starting a bit late, but we're possibly catching up at some point. This is not a promise, but that is an idea. But thank you so much for being here, so many tonight. Welcome to the event Impact the Future, co-organized by Women TechMakers Brussels and GDG Cloud Belgium. I am Federica. I work in open source tech and video games, and I'm very happy to be here with you, your host. I'm part of also Women TechMakers Brussels and GDG Brussels. And if you didn't know about this event, we are here to try to empower you and whoever would like to enter into tech, giving them resources, community, support, and just helping you shape your future. Before we dive into the content, I have a few words about Women TechMakers, if you don't know what it is about and why is it important, and International Women's Day. So Women TechMakers is a Google program. It's a Google initiative that gives resources and support to women that want to break into tech. And the aim is to bridge the gender gap in the industry. And each year, they design a topic that is going to get declined into the different chapters locally. And this year is going to be all about Impact the Future. And in fact, throughout the months of March and April, you're going to see events all under the same topic that indeed want to give to every ally and every woman that wants to break into tech support, insights, and case studies, and possibly inspiring stories. I would also like to welcome on the stage from Google Zhuang that can give a little bit of a few words about why Google wants and appreciates supporting the initiative and what they do to support women in tech. Please help me welcome her on the stage.
Hello. Hello, everyone. Welcome to join the event tonight. I'm very excited to be present as Google to support this event. So this is our first event about women tech makers and supported by Google Cloud. As you all know, that Google is very important in supporting all the inclusive and also DEI events. So I hope this event will help to foster our community for women, for all the women techers, and also to build a strong chapter in all the events like coming in this year.
Thank you. So I'm going to be quick. This is the agenda for today. We're going to try to have two sections. The first one is about keynotes. And just before the break, we have a little introduction on Gen AI. And the second section is going to be another technical lesson about computer vision. And we're going to have a break in the middle. And at the end, some pizza, possibly. So without further ado, actually, I would like to quickly say something super important. So thank you to our sponsor, because we made up this evening in less than 2 months by starting from not having the chapter to having it and actually having sponsors, having companies, organizations joining and helping us. And what is incredible is that I didn't have to convince anyone. Everyone knew that it was important to be here, that it was important to celebrate women in tech, to give resources to people that don't have the same background, or maybe they didn't even think about getting into tech, but it's something that maybe they were passionate about. So I didn't really have to convince that it was important. It was important. It was just a matter of how to do that. So thank you so much to the sponsors, also to GDG Cloud, and specifically to Cyril that really also helped me organize this. I'm going to start right into the content now, and I'm going to welcome on the stage the first speaker from Lewagon. That is going to be Caroline. So please help me welcome her on the stage with a very nice applause. The stage is yours.
Thank you. Hello, everyone, and nice to meet you. Is the sound okay? Because sometimes I tend to speak a bit loud, so just make a sign if that's the case. Thanks for having me. Let me maybe, what I want to talk about today is bridging two worlds, the worlds of consulting, or more largely business, and the world of tech and coding. And let me start by quickly introducing myself and my background, because it's going to be very linked, as you're going to understand. I studied in civil engineer in architecture, but like real architecture, like building architecture, not software architecture. I switched to consulting at Bain & Company, where it was a strategic and management, so quite a shift already. Stayed there for 5 years until I was a manager. And then I started my own company, Mobbox, which was also consulting, but specialized into mobility. And we also did softwares that were used by our consultants to be more efficient, but software that we were also selling directly to our clients. I left that company end of last year, and then I had a bit of time and decided to start, I'll explain why a little bit later, decided to start Lewagon, which I'll also explain a little bit later. And now I just finished Lewagon. I'm doing some freelance activity. Before I jump to the content, just to know who I'm talking to and the background, just by raising the hand, who works directly in tech, so really directly coding and so on. Okay. Then who works like related to tech, like not coding themselves, but maybe, I don't know, like sales for a tech company or product owner roles. Okay. And then who works or doesn't work in something that has nothing to do with tech? Okay, so quite a good mix for myself. So I started from that last category, quite quickly went into the second, did 1 foot with Lewagon into the first, and that's what I want to talk about today, how all those worlds are bridging together. And then let's maybe come back a little bit on my first job. So when I started at Bain, I did a lot of consulting projects, a lot of them nothing to do with tech. Then a couple of them in tech, where, for example, we did the digital strategy of a company, where we reorganized a full IT department. And those projects were actually part of my favorite one. So I really liked working with developers, with IT people and so on. Like somehow I found those were like at the same time, very chill, but very smart and fun people. I really liked the atmosphere, but I had a bit the imposter syndrome because I basically knew nothing about tech and I was like staffed on project about tech and IT. Then left Bain, started my own company where we did softwares. My co-founder and I, we both had an engineer background. So we had a bit the logic mind, but didn't know anything about tech. But you know, it is in a startup where you kind of have to invent yourself and improvise yourself in any role. And I took the role of product owner. That's a role that I really, really loved. I learned a lot on that role. But sadly, I was sometimes a little bit that middle person, you know, with my developer. And it was a team of quite junior developer. It was sometimes difficult to understand each other. It was a lot of frustration where some of the stuff that I would ask, it seemed like very simple to me, but it took like ages. But yeah, of course, I had no credibility to say it was simple or not. And the other way around, like sometimes like the dev would challenge me, like, why do we do that? Why is it useful? And so on. And that communication was a little bit hard. Anyway, still had a very, very cool experience. But maybe just another illustration of this miscommunication. Changing subject. Who knows what a pull request is? Okay, most of the people. If I take the definition of GitHub, a pull request is a proposal to merge a set of changes from a branch into another or into the main code. It's basically when collaborators can review, discuss, and so on until we integrate the change in the main code. And it's a bit that notion of pulling and pushing, and I'm sure most of you know it better than myself, but you know, like pushing the code from your own machine to the main code. During my 2 years at Mobbox, I was convinced that pull request was actually written pull, P-O-O-L, like in French, you know, it's like a piscine of requests because there was a lot of requests. So that's just to tell you about like how much training I needed to have. And when I left Mobox for a completely other reason, I thought I really like to work in tech. I really like to work with developer. Maybe I can become better in such a role and have such a role in another company if I follow a training at Lewagon. Then a little bracket, like, what is Lewagon? So Lewagon, and if I explain bad, there is Julia somewhere in the audience who can explain it to you at the break a lot better. But Lewagon, it's a tech school. It was founded in Paris more than 10 years ago. And it offers a bootcamp in web development, but also in data. The bootcamp is 2 to 3 months, and the goal is really to give people all the skills to be able to kick off their career in tech, or launch their own startup, or just have a basic knowledge of technology. In a few numbers, it's 25,000 alumni. It's more than 40 cities. It's more than 200 startups created by alumni, and $1 billion that were raised. And what we learned at Lewagon, I think, again, it's like quite well explained with this. So I think that was me probably a couple of months ago. Then that was me a couple of weeks ago during the bootcamp. That's me now, where after the 2 to 3 months at Lewagon, we're able to code a web app with the same level of complexity that Airbnb from A to Z. Of course, that app can probably, like, the code can still be improved. There's probably a lot of security improvement to be made. But a student out of Lewagon can build a web app of that complexity. And then I'm coming now to the important part of this presentation, is that I think code really, like learning code, really made me a lot better at my job. If I go back to a job in business, in product owner, as a founder, as a consultant, I think it brought me credibility. I think now if I worked with developer, you know, I made the effort to enter the world, your world, to understand it. I've done it myself for a couple of weeks. I think that gets more esteem from the team, and I think that's also true the other way around, that I developed more respect from the developer as well, in the sense that something very simple can sometimes take time. There's a bug that you cannot explain, even if you are the best one. I think that really helped me to understand that. I think that helped me to have a better communication. We've seen the example of the pull request. I've learned the right vocabulary. I think my communication now is a lot more precise, shorter, to the point. It brought me better productivity. I think thanks to the communication that is shorter and more effective, but also because I became more autonomous for a certain task. For example, if I need to do a simple SQL query for a database, I can do it myself without disturbing the dev. If I need to understand the last changes in the code, I can go to GitHub myself, understand it myself. And I think that's very important, both sides, because for me it's quicker, but it's also for the team it's going to be quicker, because we all know, at least the people who coded a little bit, that it's not like when you're writing an email and someone interrupts you, and when you go back to it, you just reread the last sentence and you're back again. When you're coding, it's actually a huge puzzle in your mind that when someone interrupts you, everything falls apart and you have to start all over again. So I think the team would be probably very grateful that I interrupt less. So yeah, I said credibility, better communication, better productivity. I think it helped also in better decision making, especially when there's some technical arbitrage to be made, and having a bit this bigger picture of understanding the business side, the technical side. Better project management. I think I'm more able to challenge the team. But I also can be more creative. It's happened to me in my job before that I have ideas for the application, but either I'm like, okay, I'm not going to ask that because it seems impossible, or I'm going to ask it, but it's actually impossible. Now I can search a bit myself, see if there are gems, API, anything that exists, and actually propose things that are more creative, but also more realistic. And then don't worry, this list is coming to an end, but better recruiting as well. In my startup, so I told you my co-founder and I, we didn't have a tech background, and we did softwares. So of course, when we needed to hire developers, we were heavily relying on the startup studio we were working with. I think now I can express what I need. I can have like some technical conversation. I cannot judge of the quality of a senior developer, but at least I can have technical conversation. And then, yeah, more in the startup phase, I can do an MVP myself. I cannot probably, at least like at my level, I cannot code something great, but at least I can do an MVP, find investor, and then hire the proper team. So yeah, to sum up, better credibility, better communication, better productivity, better decision making, better project management, better recruiting. I think that's a lot of learning beyond just the code itself. And then, to finish this presentation, I have two last messages. So if I've been super boring until now, or if you haven't listened, now is the time to listen, because I'm going to sum it up. My first message is put yourself in your coworker's shoes. I gave you plenty of examples of how learning code made me better at a business or product role. I think the contrary is super true as well. And a developer who understands business, who understands why we develop something, what's the goal of that, it's extremely valuable for a company. It's something we used to do in my company, where we ask some developer to come directly in the client meeting to listen, and it was super valuable. And then my last message to finish, as you are in the driving seat of your career, and I hope somehow my journey from architect to consultant to co-founder to learning to code can somewhat inspire some other. I mean, just like when you are in a car, you can decide, to follow the traffic, but you can also decide to take a longer road, but where you see nicer landscape, or you can jump off of the car, jump on a bike, and actually pass that traffic lane. That's the same with your career. I think at any point you can change, you can learn new stuff. And fortunately, I think the tech world for that is great, because what I can see also in the tech world is that your motivation is a lot more important than your diploma, whereas in a career like lawyer or doctor, it's actually not the case. So that's a great opportunity, and I'll end on that.
Thank you. That was super inspiring. So thank you so much, Caroline. I think it's a very good story and inspiring to know how important it is to just get curious about tech so that you can get better also at your job. So I'm going to be quick, and I'm going to present the next keynote that is going to be as inspiring, and it's going to be presented by Technocité. So please help me welcome on the stage, Bérengère.
Thank you. Well, good evening, everyone, and thank you to Frederica to give me the opportunity to explain you tonight what we do at Technocité. So I'm innovation manager there. It's a training center, and we train unemployed people or people who want to have a new career in everything that's related to technologies in the creative industries and the information and technology communication industries. So today I'll share with you how we target inclusion, and more specifically for women. So this is really important to us and to me too, because I'm coming from a more political technologies and also that background. So I'm not really into coding and information and communication technologies, but I learned that from experience and from the different job I did. And so it's also important to empower women, explaining them that's not because they have been trained specifically in technologies that they cannot actually have a role into tech, and have and also empower other women. So why training in tech can change your life? It's because even if you don't have a tech background, you can actually learn a lot by different training, by being inspired by other women, by belonging to different network and to an ecosystem that's going to bring you into technologies. And so today, we live in a world that's incredibly driven by technology, but it's not only what technology brings to our world, but also what, with technology, we can impact the world with all those challenges that are coming forward. And so you have everything that's related to ICT and creative industries, it's interesting because we can cross actually technologies and creativity. And this is where innovation happens, and when there are interesting things that we can actually develop. And it's important that we bring women into that, because we know statistically that only 25% of the jobs in tech are held by women. So now we need to raise that, because it's important to actually have have more diversity and more inclusion into technologies. And we noticed at Technocité that there are different barriers that make women not tend to go to technology because of experience, because of, stereotypes. Like we talked about that earlier, that maybe we think that we do not belong into technology, although it's just a stereotype and we need to break that. Sometimes we also lack role models, because we have more men than women that are in those, for example, when you go to a meeting and you have many men and you are the only woman there, so how do you do to just being empowered and just bring the topic and be proud of what you are also representing? And the job description, now with all that's related to artificial intelligence, you have got a lot of BAs and things like that. So you need to just make sure, and this is the role of women, to actually make the job description also accessible to women. And so this is why we think at Technocité that it starts with education and actually making a more inclusive approach to tech education, and integrating technical skills with also soft skills. Because, for example, at Technocité, we have really strict programs that are really high-tech, and now we notice that women, they also need to have more information about soft skills, about how to go to do presentations, how to be self-confident, and many soft skills like that are sometimes even more important than the hard skills. So combining human and technical skills, it's important. And this goes through also fostering, in the ecosystem, research with businesses. And this is why we are trying also to offer our trainees with a lot of contacts with businesses, with researchers from universities, so that they can work on projects during their training that will actually bring them directly to topics that are being dealt with on a daily basis in companies, and that will actually raise also the interest for women to work on things that are really practical, that are really having an impact in our daily life as well. And so this is why we are developing a program that's called Girls Connect. So this program is really an approach that's between a regular training that, you go through a training in different centers, go from 8 o'clock to 5 o'clock at night. And this is not flexible enough for women because of their life, because of what they do on a daily basis, if they have different jobs, if they have kids. So this needs to be a lot more developed to adapt to their own needs. And also, we need that approach that people will have access to training programs and things like that online, so that if they cannot come to a place, they can also work from home or from the office if they have another job. So it's just to have an approach that will be more accessible, more inclusive, and as well online as on site. And this program, we develop it with people like Leila Medan. I think you're here tonight. Yeah. Okay. Leila she has an approach with women who have projects, and just to help them on a one-to-one approach as well, on to give them experience from other women and to have this info from more entrepreneurial approach. And sometimes like people need, mainly women, they need a little push to go further and to actually go for their project and build a business and those things. Like it's not easy to do, and being with other women, being inspired, and that's being part also of an ecosystem, of a network, is really important. So this is why our program, like we are testing like different approaches with experts, with trainers that have their own job in the tech world, and that will be like the most appropriate person to help other women to be empowered and to actually go their own way. So this is also why we are trying, because Technocité is based in Wallonia, so it's between Mons, between also Charleroi. We also go to Namur, to Liège, to Tournai, and we are trying to develop an ecosystem of proactive women, trying to help other women to access technologies, to access trainings, to access entrepreneurship. And we have different events coming up because we find that being together and actually gather all our different networks helps spreading the word and helps also giving more motivation to those projects to actually happen, take place, and involve other women. So on the 25th of April, we'll be at Asiska in Charleroi. Asiska is actually a great place because it gathers everything that's related to research, to entrepreneurship, to training, and that place is really like it's a hub, like where a lot of things happen, innovation and so on in different sectors. And we'll have the event that on the 25th of April, which is the Worldwide Girls in ICT Day, and we take the opportunity to have women testify about their own job, what they do, how they reach the place where they are, and we will also have Federica coming to this event and presenting everything about women TechMakers. And on the 16th of May, the KIC, I don't know if you know the KIC festival. It's a famous festival in Namur, and it's about all related to creative industries and information and communication technologies. And the KIC is organizing an event that's Women in Digital, and it's going to be a big conference with a lot of people talking about inclusion in tech, and most in particular for women. So I found that quote interesting. It's about in the future, so there will be no female leader, there will just be leaders, because what we are trying to do is, of course, dedicated to women, but we think that inclusion, it's about everyone, and this is why we are doing this, like to actually inspire people and help them to access training and about inclusivity, and it's really important for us that actually women are going to be leaders for sure, but everyone needs that, and this is why we are working on those training programs. And if you're interested, just come and talk to me, and I can give you more information and attend our events in Charleroi and in Namur.
Thank you so much. Thank you so much. I hope that was interesting and inspiring, and I think it's very important to stress that indeed it's called Women TechMakers, the program, but it's important that it's open to anyone. We talk about the diversity. It's also about diversity of your background. So you don't need maybe to have a technical background, to have technical interest, and it's important that also these trainings can help you get into tech without necessarily having a technical background. So next, this is a little recap about what we saw each other. I'm laughing a bit because actually it's my turn, so I'm buying some time, because indeed I am an example of someone that doesn't have a technical background, but does have technical interest. So today we're going to do something together. We're going to learn a little bit about the Gen AI. And in particular, we're going to give definition to some of the most important buzzwords and important expression nowadays, like artificial intelligence, machine learning, deep learning, large language models, and generative AI. And possibly you're going to get just enough information to make you dangerous at parties. So beware on that. So let's start from AI. AI you might have the perception that it's something very recent, but actually was founded as a discipline in the mid-50s, and in particular in 1956. And the goal was to make machines intelligent, that is, to mimic human behavior. And some output of these artificial intelligence were, for instance, solving very specific logic problems or checkers, so something like that. And you could definitely see some sort of artificial intelligence, especially when the computer beats you, no? And you can definitely see that there is some sort of intelligence there. And since it's about a machine doing something, very often is also associated with machine learning. However, today we learn together that artificial intelligence is not machine learning. Actually, artificial intelligence is the discipline, so it's the field. And machine learning lies within it, so it's a subset in a way. So what is machine learning? Machine learning, if artificial intelligence mimics the behavior of humans, so how humans react and answers, machine learning mimics how humans learn. So something very unique, I would say. And how do they do that? Through two very complex things, but I'm going to try to make it super easy because that's how I understood them. So machines learn through unsupervised learning and supervised learning. Let's try to explain them one by one. So supervised learning is when you give your machine data. Data is the food of the machine so that it learns. And the data is labeled. So it has a label that says what that data is. Let's go to a nicer example. So we play a game in which I am a teacher and you are the machine learning model. And the machine learning model is also like a kid in preschool that doesn't know anything about fruits. I'm going to present you a basket of fruits, and I'm going to give you one by one a fruit labeled with telling you what is it about. So, for instance, I'm going to show you an apple, and I'm going to tell you this is an apple. I'm going to show you an orange, and I'm going to tell you, I'm going to label it as an orange. After a while, let's say 70-80%, that we went through the old fruit basket, I'm going to ask you, by presenting you the object, what do you think this is it? So you've been trained on the labeled data, and possibly you're going to give a correct answer. So this is basically supervised learning in machine learning. So you're going to learn through labeled data, and you're going to predict the future. So unsupervised learning, it's when you got data, but at this time, you don't have labels. So you have no clue, and you need to learn by clustering, making groups on the data you have presented. Let's give another example. This is another fruit basket. It also gets cuter exponentially. And I'm going to present you. You are always the same machine learning model that needs to be trained, that is as a kid in preschool. And at this time, I'm not going to tell you anything. I have the same basket, but I'm going to just tell you, group whatever you see. So at some point, we can assume that the kid is going to group all the fruits that are orange, all the fruits that are red, all the fruits that have a certain shape, and so on and so forth. And of course, this is a different kind of problem, but indeed is another way in which machines learn. Now we move on and we go a little bit deeper, because we have defined AI, machine learning, and now something that lies within machine learning, that is deep learning, and deals with way more complex problems. Simply, it's something that mimics the human brain, basically. So I'm going to also show you how it does it. So if we have seen at the beginning that AI mimics human behavior, machine learning mimics learning, deep learning mimics indeed the brain. So it uses something that is called artificial neural networks to process more data and solve more complex problems. This is how it looks like. So this is a neural network, basically. You see the different layers and the output. So it's something that indeed resembles a little bit how our brain works. And an example of this is a little bit more businessy. So through a neural network, you can, for instance, predict sales based on media channel budget. So you have some input layers. You have, for instance, different channels like digital, TV, radio. Some layers, some input can be more important than others. For instance, I can say that digital is more important than radio, and that you're going to have an output. So indeed, as you can see, at this point, is definitely a more complex problem. And now we go to the point. Why is it important to define deep learning? Because Gen AI is part of deep learning. And Gen AI is a type of artificial intelligence that generates content for you. That can be text, code, images, 3D objects, audio, video. So that's even more complex. And if we want to focus a little bit about that type of generative AI that focuses on text, we need to also define large language models. So large language models are the type of generative AI that indeed focuses on the text creation, text generation. And they are general. So I don't know if you ever had the chance to use ChatGPT, something like this. So, you're going to have general answers. So they are big, they are general in purpose, but you can do also something that is very interesting. So you can pre-train or fine-tune them. So what does it mean? It means that, for instance, if I want to train a dog, okay, I have a basic dog, I can train it to sit, to come, to lay down, to stay. And this is, my general model, okay? This is a general model of a good dog, okay? But what if at some point I want this dog to be a little bit fine-tuned and put it under a special training? So it can become, for instance, a police dog, a guide dog, or a hunting dog. So this is the same that applies with the large language models that get fine-tuned through the special training. And, just to sum up, large language models can be trained to solve common language problems, as you can see, text classification, document summarization. This is the general usage. And then it can be tailored for instance, education, sustainability, healthcare, and so on and so forth. What is important that I want you to, kind of keep in mind is that they do not think. So large language models do not think on its own, even if sometimes one can be tempted to believe so. But they learn through the data, through the patterns that they see in the data set. So we're going to have an example here that I think is going to be interesting. So if you have to fill in the blank on this phrase, this sentence that says, I'm making a sandwich with peanut butter and... Some of you may be tempted to add a certain word instead of the other based on your training data. Your training data as a human is your education, your culture, where you're coming from, your age possibly, your taste at some point. And indeed, so large language models in this case, they're going to fill in the blank based on their training data and the what is most likely to come next. So it can come jelly, jam, banana, fluff, jelly time, maybe if it's Italian, Nutella, something like that. And why is it important to say that? Because since they, of course, learn through patterns, it's important to say that the answer that you get is as qualitative as the prompt that you're using. So if you're accurate, you have a qualitative prompt, you're going to have a better result. In fact, sometimes what does it happen is that AI also can have hallucinations that are errors that are, to me, hilarious. So sometimes are nonsensical, sometimes are grammatically incorrect, but sometimes actually they are pretty convincing, but they're just wrong. So this is an example of a chat that says, how many M's are in the word weather? And actually ChatGPT says there is one M, but then we ask, are you sure? And then it apologizes. So it's actually convincing in the answer with that full stop at the end of the phrase, but that you need to double check. And hallucination can also come in a visual form. So since GenAI, we can produce also images. This is a sort of hallucination, so it's quite special. So just to sum up, the answers you get depend on the questions you ask. And I would like to finish the presentation with a quote that I think is quite insightful by a philosopher called Ludwig Wittgenstein, that says that the limits of my language mean the limits of my world. Because I think it's inspiring to the fact that, you know, the way you also craft and learn is really, really shaped by the language and the world that you're in. And to me, it's inspiring to, you know, never stop learning, possibly always expand my view of the world, and also maybe craft better prompts. So thank you so much for your attention. And yeah, we have a break now. So thank you so much. Okay. It's always me. Oopsie. Always me. We have a break. So I'm very happy about that because I put stickers one by one on the Smarties because, you know, we are smart here. Yeah? So please take them and I'll call you back in 10 minutes, 10, 15 minutes. So it's in the other room. Thank you. Hi. Are you good? It's going well? Ready? Ready for the last session? It's going to be super, super interesting. Of course, I'm biased because I saw already the slides, but I'm not going to give you any spoiler. So first off, thank you so much for BeCode. That is the sponsor of the last sessions. Please, like a very, very, very loud applaud for two speakers from BeCode. We got Vanessa, please join me. And Leila. I'm going to keep this.
Testing, can you hear me well?
Can you hear me also? Yeah. Great.
Okay. All right, so for the last session, we'll be diving deeper, actually complementing what Federica has already shared, so this is really great for us. So I'll first introduce our talk. We'll be talking a little bit about computer vision, so we'll try to make it beginner-friendly, but we will have a Q&A in the end, and we really want to encourage participation from all of you. But we're going to do computer vision with Teachable Machine. This is a Google product that we'll introduce in a little bit, but hopefully by the end of this evening, all of you feel empowered to try it yourself and build your first computer vision model. I'm Vanessa Rivera Quiñones. I'm originally from Puerto Rico, but I'm also an AI coach at BeCode, and also an ambassador for a women in tech community called Technocité. So if you're interested in tech or passionate about tech, I encourage you to take a look at that, and I'll let Leila introduce herself.
Hi, so my name is Leila. I'm Belgian. So I was an AI coach for a little while at BeCode. Now I've transitioned to a data science role at Customs for security. I did most of my career in natural language processing. Now I'm transitioning to computer vision, which is what this talk is about today. So yeah, let's go.
Yes, let's get started. So before we get started with the computer vision part, I wanted to introduce what BeCode does. So we are a social-driven impact digital coding school. We teach web dev, cybersecurity trainings, AI, where I'm a coach, right? And our goal is to help job seekers transition into careers in tech. We're sponsored by governmental agencies like BDB, Le Forum. So we're really trying to include people from all different backgrounds, all different experiences, and make them and include them in the tech world. We do this by long, short, and B2B training, so feel free to look at those if there's interested. And for us, the most important is that our trainings are free if you're a job seeker. So we really want them to make this accessible to everyone, regardless of their background. So what we're going to do today, we'll introduce AI and computer vision. We'll give a short demo of a tool that makes it accessible for you to build your own models. But also, we want to spend some time talking about how it works behind the scene. And hopefully, you'll be inspired by some of the projects that previous and current BeCodians have done regarding computer vision. And already, Federica gave a great explanation of what is AI, right? But artificial intelligence, what it's trying to do is to mimic the problem-solving skills that humans have. And you already saw some of this in the previous talk. There's machine learning, there's natural language processing, there's generative AI, which we had a great talk about, and then we'll be talking mostly about computer vision. But what is computer vision, just in the big picture? So computer vision is a subfield of AI and uses algorithms to understand images and videos. We saw a little bit of an example with text before. But you can think about all sorts of data, and image and video data is just like anything else. But our goal is to build algorithms that can see in the same way that the human eye can. If you think about what are the common applications of this, people think a lot about self-driving cars, right? If you have a self-driving cars, how do you detect pedestrians from traffic signs from the road? But also it has many applications in the research area as well. Let's say that you're trying to be a bird watcher or you're a conservation enthusiast. Maybe you use that to identify species of birds, right? The complicated thing about computer vision is that it uses neural networks. Leila will explain a little bit about that later on. But it tries to mimic the brain, and this is where neural network comes from. But a question from the audience, and then maybe we can share a mic. I want to know, what are the images shown here? Can anybody tell me? Raise your hand so Federica can give you the mic. People are now questioning.
This is not a trick question.
This is not a trick question, I swear. It's not a trick question, but... Okay. Maybe we can start for the image from the left.
Cat. This cat.
Okay.
Yes.
I think so.
I think so.
Okay, cat. And maybe for the image from the right.
This dog.
Okay.
Maybe.
And maybe I saw someone else raise their hand. Do you agree?
Yes, you agree?
I agree.
Yeah.
Okay, and the person in the back?
Okay.
You agree?
Yeah, I see a dog that maybe he's interested in something in front of him, like
Okay.
a toy or I don't know, something that they're interested.
Okay, but then I'll tell you a second question. How do you know? How do you know that that is a cat and that is a dog?
What data, though?
It's because we have data in our brain.
Yeah, you have that.
Yes,
so
data
can you give an example?
Data similar to these photos, and we have label according to, for example, cat. So this is cat.
That's a great explanation. It's just like great example.
Yeah.
So anyone else, how do you know? So if I tell you this is a cat, how do you know that it's a cat? What makes it a cat?
Whiskers.
Whiskers. I see a person in the back.
They have different body structure.
Different body structures, yeah. Maybe one more from the audience.
The ears are different, the eyes are different, the nose is different.
Mm-hmm. Yeah, those are great points, right? Maybe you say, okay, cats usually have pointy ears. Some dogs do too. Maybe you say, okay, the body is different. The faces are different. Dogs usually have like a snout, so it's more outwardly. But for a second there, which is really interesting, I had you questioning if you knew what a cat and a dog was, right? So the purpose of this exercise is that, right, computer vision tries to mimic how we see. But oftentimes, it was very well explained in the front, someone told us these are cats, these are dogs, and eventually we ourselves learn what is a cat and a dog? So then no longer using images, right? Maybe you've never seen this dog or this cat, but you can identify it. And that's what computer vision is trying to do. So we thought it would be fun to walk through an example of how this works in practice, coming from the field of conservation. So we call that conservation. And again, we're going to try to classify wild species that appear in camera traps from images. And maybe one more question is if you're brave. Thinking back what Federica told us, right? So we have images. Let's show them here. We have 3 images, or 3 types of animals: cisvets and genets, leopards and monkeys, right? And we're going to use this to build a model. This is what we call a classification problem. I will keep it here. In our example, we're going to have labeled data, so kind of like little kids or how we learn when we are children. We're going to say, okay, we have a bunch of pictures with the labels, leopard, monkeys, and cisvets and genets, and we're going to try something to build something that can predict it by seeing the image. And this is where Teachable Machine by Google comes in. This is a great platform for learning. It's no code, so you don't need to be a programmer to interact with it. And it's web-based, so you can create a machine learning model just by giving it the data, and there's many data sources out there for you to try. It has projects for images, we'll see that in a second, sound, and even pose detections. But right, I encourage you to check it out because I think it can be a very powerful tool. And it's as simple as this. How it works is that you can upload images that you have for different classes. Here, in this example, someone with their dog. You push the button and you train your model. So, of course, it seems very magical. We'll dive into the details a little bit later. But I wanted to show you an example for our conservation project. So you see here, our first step is data. It always starts for data. So we have 400 images from each species. You can see here that you can upload them or use a webcam. You can train a model. This is a bit more advanced for those who don't know the vocabulary, but the idea is that you can prepare your data for a model. You can modify a bit how it works, right? And then this is all the steps you need to train a model. So I'm going to wait a little bit, right? It can take some time. But not only that, with Teachable Machine, just by pushing the button, you get to see how well the model is doing. So here we see how, as it's training from the data, the accuracy is improving for both the data that is being trained on, and we're going to keep a little bit of data separate to see how good it is. And you can see how it improves over time. So in this very, I would say, beginner-friendly platform, you can then train your own model. Some caveats and to mention is that when you build this type of tool, no matter what you give it, it will predict. We built this model based on monkey, leopard, genet data, but both Leila and I tried, and it turns out that I'm a leopard and Leila is a monkey. Just to keep in mind, right, you can then use it, upload an image, and it will give you the percentage of, right, which animal you are. So it's as easy as that. So we said that we were going to dive a little bit deeper also on how you do it yourself. But I wanted to first mention the pros and the cons, right? You saw that for this demo, it's very easy to use. You have a quick model that you can then download, put on your website with very little coding. It's great for proof of concepts. If you're a business, say, hey, my team wants to build this application. Here you go. This is how it could look like. And you can reuse it. So really, if you're curious about computer vision, I would try it out. But right, nothing comes for free, so you might be wondering what are the cons. Well, you don't really get to see the process behind it. We'll show in a little bit, right? It's kind of magical. So if you want to understand how this works, this is not the best tool. You don't have control about what happened in each stage. At some point, some choices were made for you. So you can customize it as well. But right, I will pass it on to Leila so she can talk a little bit about the behind the scenes.
Thank you. So I'm going to get this thing. Okay. So now let's get into the more technical part of how computer vision works. I'll try to keep it somewhat easy to understand, but if there's anything that you're wondering about, please keep it in mind and ask me or Vanessa at the end of the talk, okay? Okay, great. So we talked about neural networks. Federica talked about neural networks, but what are they? So I'm not going to start by explaining everything about how the brain works, but we have neurons, right, that are connected to each other, and this is what we're trying to represent here. So a neural network has two different types of components, nodes and layers. Each layer has a bunch of different nodes, and you can have as many layers as you'd like, pretty much. And so those layers communicate with each other and give you the output to your question. In this case, we're trying to figure out if this image is of a cat or a dog, and we will feed it in what is called an input layer. It'll go through the whole neural network, and it will end with the output layer saying if it's a cat or a dog, pretty much. So we're going to explore the layers of a typical neural network that is used for computer vision, yes, which is called a convolutional neural network. I'm going to call it CNN, just to let you guys know on the acronyms I'm using. So here you can see, courtesy of CNN Explainer, an overview of the different layers of a CNN, which basically here is trying to classify what is the image, the espresso cup over there. Okay. So the first one is the input layer. So the input layer roughly represents your image, right? And what is an image for a computer? An image for a computer is basically pixels, right? So you have the location of your image, you have the value, which is the pixel, and since we're using RGB images most of the time, and in this case we are, we have three different channels. I will not get into that, but we have the red, the green, and the blue channels that have different values, depending on the color of the image. Then the next layer that we typically use is a convolutional layer. So what this does, it's a little more difficult to grasp, is that it will try to detect features using filters. So basically you'll have this little sliding filter. I think I have a slide on that afterwards, but you'll have a little sliding filter that will try to detect specific features. So for example, in a car, it will eventually detect that there are round things that we call tires. On a cat, it will maybe detect pointy triangles for the ears. And it will do that for a bunch of different things. And some of the filters will be useless, right? Because you will not detect a specific feature that you're looking for. And some of them will be very useful. So yeah, here you get a more close-up view of the little filters. And here you can clearly see that we're starting to detect a cup. We don't know of what, but we're detecting a cup. Usually, so after going through the convolutional layer, we have what is called an activation layer. So an activation layer is used to pretty much introduce some non-linearity into the model to be able to grasp more complex features. And it may seem a little weird explained like that, but if you try to understand, the seasonality, right? It's not always explained by a straight line that is linear. Sometimes it's explained by a much more complex pattern that can only be explained with nonlinearity. Well, this is exactly the same here. And ReLU is one function that is one activation function that is typically used because of how simple it is and how much it speeds up training. Then we have the pooling layer. So I think the image is a pretty good representation of this. The pooling layer is used to summarize the features of a certain location. Because, let's say, we were talking about detecting cats, right? And we said they have pointy ears, usually. Most of the time. I mean, all the cats I know have pointy ears. And so in an image, you saw the little cat that was rolling around, right? So its ears were like pointing down. But then you could have a cat that is sitting, and then the ears will be pointing up. And probably not in the same place in the image, right? Well, the pooling layer helps with that, because since it kind of summarizes the features over a certain location, what it will do is that it will kind of desensitize to the location itself. So we'll be able to detect pointy ears, not necessarily in the exact same pixel location that we did on our training data, but overall. It also helps reducing the number of parameters, because training a convolutional neural network, as you might imagine, takes quite a bit of time. So pooling layers are also super useful in that case. And for the last two layers that I'm going to explain today, we have the flatten layer and softmax. I'm going to go very briefly on them because I don't want to get into the whole math. But basically, a flatten layer will flatten your data, because at this point we have 3D data that has gone through convolutions, through pooling layers, and that's fine. But to be able to get a probability of the image belonging to a class, we need it to be flattened into 1D vector. So that's what it does, pretty much, without any kind of other operation. And then the softmax operation, as I said, will give a probability that sum up to 1 for the image belonging to any of these classes. So in this case, it has a pretty good understanding that it is an espresso, but it's not ruling out that it could potentially be an orange, probably because of the round circle that is the espresso. So now, when you put it all together, so we have our 3 images that are our input features. We extract the features from a bunch of convolutional layers and a bunch of pooling layers. We usually have them stacked. After we're done doing all that, we flatten our data. We put it through a fully connected layer for classification between civets, leopards, and monkeys. But now, how do you do this? How do you build all this? Well, there are different things that you can do that Federica already introduced, so that's amazing. So we're going to explore 3 different ones, including transfer learning with fine-tuning, and do it all from scratch, which is my favorite, but that needs a lot more investment in time and resources. In terms of tools to execute the approaches that I just talked about, the most used are, Hugging Face, that is a very good research library of, I don't know if I would call it library, but of different models that you can use for transfer learning, pretty much. TensorFlow and PyTorch, which are frameworks to code neural networks that are roughly equivalent. Prove me wrong. And Keras is some kind of an abstract layer on top of TensorFlow that is supposed to make it easier to code. OpenCV is dedicated to computer vision. So, transfer learning. So, as humans, when we encounter a situation that we've never seen before, what we do is that we are going to take our past experiences, take the one that is the closest, right, to the situation we're encountering now, and we're going to try to make a decision from our previous experiences. Well, transfer learning is exactly that. So here let's say we have a model that is super good at classifying raccoons, at identifying raccoons. And now we need to identify tanukis. Well, since you can see that they share a lot of the same features, what we could just do is use our raccoon model and apply it to tanukis. And, you know, if we give it our new data, it will be able to say this is a tanuki. This is good to do when you have a small data set or low quality images, stuff like that. And that you have data that is from similar domains. So here, raccoons and tanukis. If you're trying to identify what an elephant is, I wouldn't recommend using your raccoon model. It probably won't give you the same results. And it's also good to use if you don't have the resources to train your own, because as I said, it's quite intensive to train your own computer vision model. So taking one that is already done and trained is quite nice. So how you'll do it in practice, I'll have a little schema, is that what we said? Later. But roughly you take the layers from a previously trained model on the raccoons. You're freezing them, which means that everything that was learned through those layers in those nodes, the values that are comprised in those nodes will be just fixed. Then you will add some new trainable layers. Usually you add one. And once you basically give your new image, all the layers that are frozen will stay frozen. It will go through all those values. The mathematical operations will be the same. And then at the last layer, you'll be able to learn some new things about how to identify tanukis, but in a very short way. So this is what it looks like. So you have your input data, your tanuki, you're extracting features based on the features of the raccoons. Then you'll classify on the new trainable layers, and you'll have an output. Is this a tanuki? Yes, no. Quite simple. Now, we've got transfer learning with fine-tuning. It's roughly the same idea, except what you'll do here is that you will unfreeze more layers. That's pretty much it. And you will retrain that. So it's somewhat of a hybrid situation here. You can do that when you have a larger data set, but it's still not big enough to train your data from scratch. Or you want to specialize your model to a specific task because you actually want to detect the specific features of a tanuki and not necessarily base everything on a raccoon. And also, it still applies if you don't have the resources to train your own model. As a general remark, the more resources you have, the more layers you can unfreeze. Pretty much it. So here you can see the difference. So we have somewhat of a hybrid situations, as I said, in the extraction of features. Part of it is based on the raccoons. Part of it is specific is going to be trained specifically on tanukis. However, what's good with that is that you won't be starting from purely scratch, because there's such a thing called initialization of layers. And here they won't be initialized at random. They will be initialized on something that is similar, which is the identification of raccoons. So even if you're still learning on them, you start from a good base. And last but not least, do it from scratch. This is only to do if you have a lot of data, you have a lot of computational power, and you cannot find another model, another context that is trying to do the same thing as you are. So what you will do is you will need to first prepare your data, your test and train data. Do remember, though, that it needs to be of high quality and very highly representative of the question that you're asking, because as Federica said, you get the answers to the question you're asking. And you need to know what question you're asking before you start preparing your data. Then you will create your own CNN architecture. So you will choose everything here. You'll choose which layers do you want? Do you want convolutional? Do you want pooling? How many do you want? Which hyperparameters? Vanessa mentioned a bunch of little advanced things in the teachable machine. If you don't know the vocabulary, those are hyperparameters, and you will need to decide all of these. You'll have to make sure that it doesn't exceed your performance capabilities. And finally, you'll be able to train and test your model, and that will loop around for a little bit of time until you figure out the correct architecture and the correct type of parameters and the correct data to answer your problem. So, yeah, again, this is a little visual explanation of this, where you do everything on your own. Here you go. Now you're all ready to start your own convolutional neural networks. I mean, I do encourage you to look more into this. It's quite fascinating. It's probably why I just switched to that job. But yeah, I hope you like this. Thank you. I'll transition to. It's not over quite yet. I'll just transition to Vanessa, but my part is over.
Yeah, but so maybe a quick poll, right? If you have to pick right now, who would go for teachable machine? If you had to build your model, who would try that first? Okay, I see like maybe six or seven. Who would feel ready to do some transfer learning? Okay, so a few people, that's nice. Transfer learning with fine-tuning. Okay, like 2 people, cool. And who would want to build them from scratch? Okay, I mean, I hear some laughter, right? You seem like this talk for us was more like a menu, right? Giving you many options of involvement. But I hope that what you've got so far is that this thing that we do so naturally, let's say identifying a cat or a dog, being able to say that is a car, that is a chair, that is Leila, right? Actually, when we build these things ourselves, it can be quite complex. So I find computer vision a fascinating field because it really showcases the complexity of our human brains, right? Things that we do kind of naturally without asking many questions. Maybe you haven't wondered, how are you able to tell a cat from a dog, right? This is how we build it, or the many ways we could build it, and it can be quite complex. So I hope at the end of the day, right, you feel like you learned something new, you have some new tools to maybe try out for yourself. But we wanted to end the talk with some maybe inspiration. Because computer vision is part of our training, depending on the projects we get by companies. But a lot of our learners do end up quite fascinated with this area. So some of the things you could do if you train or learn more. So this is from a previous group a few years ago. They built a mold detection app. So the idea is that you can use this in healthcare, using maybe images that are from cancerous or non-cancerous spots on the skin. You can build your own way to detect, right, what type of mole it is. Is it cancerous or malignant or benign? And could even provide information to help make a diagnosis. So we talked about conservation, we talked about self-driving cars, but there's many fields that are using computer vision, and healthcare is one of them. Another one that I'm quite fond of, even though I'm not super sporty myself, is for sports detection. So here on the left, we see one of our learners who was very passionate about climbing. They use some of the tools you saw here, transfer learning mainly, to create a model that would track how his pose is progressing during his hobby, which I think is a very cool and personal project. And we also have some of our learners who've done an internship in a company in Antwerp called Trackbox. And their whole premise is to be able to identify players in football, either their jersey or their positioning, identify the shape of the playing field so they can provide live tracking for players. Another really cool application is virtual reality. It's something that we didn't really discuss here, but virtual reality is sort of recreating, right, the experience of being somewhere else through tracking different points of your body. And I wanted to give this example. It's quite recent. A learner of ours decided to do a tech talk, like a presentation like today, using this technology.
Hello, everyone. Welcome to Extended Reality. I am your pilot and guide for today, Alice. I hope that maybe by introducing you to this topic that is going to be something that will catch your attention and maybe bring a bit of a, popularity to the virtual reality scene. It's unfortunately a sort of somewhat niche hobby at the moment, but it has actually a lot of different applications in current society, and it's something that I think would be revolutionary for a lot of people.
So, right, it's not exactly how we show computer vision works, but it's one of the, I would say, cousins in terms of applications. And it's quite popular also in gaming and to give people experiences outside of the realm of their life. And another one is creating cover art. This is a little bit maybe similar to the generative capabilities Federica talked about. So you can extend that generation to images. So say you train a model, right, based on images of real images of album covers, and then maybe use that to train a model that then could create new images based on that. So those are some of few examples. Maybe I wanted to add that before going to the Q&A, that even though today we presented all this topic kind of in a disjoint way, right? Text separate from images, videos separate from text, or maybe machine learning separate from deep learning, all these things intersect, which is a very interesting and fascinating thing about tech. So think about extracting text from a PDF scan, then you need to use computer vision, right? Not only that, then you need to use maybe other tools to understand the text. So the fascinating thing about computer vision and this and tech in general is that no matter what you learn, you'll find a space for it to apply it. So I really want to encourage you to find what makes you excited, what brings you passion, and explore it a bit further. And here are some resources to help you with that. And that is it for us. I hope you learned something new, and we are open for questions. So thank you, everyone. Thank you, Federica, for organizing this, and we'll be happy to answer.
Thank you. Do we have any question? Or you can definitely ask. Oh, we got it.
Yeah, maybe in the meantime, I will add, right, our presentation is quite technical. I know this is an event for women in tech, so we can also talk about our general experience. We're open for any question you may have, but go ahead.
Thank you for the great presentation. I have a question regarding the data, because Leila mentioned data. A lot of data is required to have a good AI output. So when you took the example of the healthcare with the mole, in terms of owning the data, who owns this data? How do you, as a startup, get around gathering all this data?
Well, it really depends on the kind of data that you need, right? So I don't know if we're taking the mole example. I didn't do it myself, but as an intuition, I'd say that I would probably partner with a hospital of some kind, right, to get the data, because you're not gonna just get mole data online, right? So I would ask for the partnership of a hospital, of a dermatologist, something, and then there's the whole question of personal data and GDPR, etc. But that's, agreements that are taken between the data provider, pretty much, and the data scientist, but that is very different for each case. What I can say, though, is that not in computer vision, but in NLP, in my job, I've had a lot of times to create my own data, synthetic data, or to create it with my colleagues. It took an insane amount of time because sometimes the data is just not available. And I would say that it is the greatest challenge. It's clearly not building your own network. I mean, it is difficult, but it's not the hardest part. It's definitely finding the correct data and having enough of it. That's the greatest challenge.
Yeah, and to add to that, right, there's a lot of open source alternatives, but it does really depend on your context. For the example with the mold detection, it was a research data set that was made publicly available, but then, of course, is limited in the amount. So for startups, I would say to try to find what's open source, but, right, it can be challenging to find for a specific context your data. And like we've shown here today with other presentation, it all starts from the data, so it's quite important.
Yeah, the issue is that typically startups focus on innovation, right? And so it's sometimes very difficult to find similar contexts because you're trying to innovate, so it's all in the name, right? So, but yeah.
And in terms of liability, so especially in the health tech industry, what if there's a wrong diagnosis on a mole?
Yeah, this is a great question. It's something that is still discussed a lot in the field. I think that the main thing that we try to encourage is using this as tools to help the human. That a tool shouldn't be diagnosed in itself, but be a flagger of, hey, this is something you should check out. So actually, I'm not sure if I can go back to it, but it's something we talked with our learners about, and I think this one has like a disclaimer in the bottom. Let me see if I can play it again. That says, if you are concerned, go to your doctor. But yeah, it's tricky because it's who is responsible for the diagnosis can be quite complicated question legally. Yeah, but very nice questions.
Yeah, there have been a bunch of scandals regarding false diagnosis, but also like racism and sexism, etc., in the judiciary system, which is the reason why currently it's not used as, a diagnosis tool or a decision-making tool, right? It's more of as an advisor, pretty much. Yeah. Because it can be biased, and that's a whole other
conversation.
Whole other conversation. We could stay here all night.
Thank you so much.
Thank you for the question. Other questions? Let's give some time for the mic.
So I hope it will be clear what I ask. We talk about like the good way, so he can recognize leopard and raccoon. So if I give images of leopard and raccoon, it will recognize it. If I give like a duck in 100, what happens? Is it gonna decide himself like I don't know what is it, or it gonna like force himself to say it's a leopard?
Yeah, that's a great question. Indeed, when we build this tool, it's built to give an answer. It doesn't have the capability unless we build it to say, I don't know. So that's quite tricky. For example, if I now use that model, give it like a hot dog, it will say, okay, it's maybe a 50% leopard. And you're like, that doesn't make sense, right? But it's only built to detect based on the data. If you give it any other data, it will make a prediction, but you know that it won't be realistic.
Something you could do is something I did in one of my speaker identification projects back in the day, is that basically you add an other category.
Yes.
So basically when you have your machine learn, you will give it, images of leopards, civets, and monkeys, and other animals, right? And that way, when you give hopefully my picture, it will say other and stop saying monkey. Yeah. And that's kind of the idea of how you could give your model the idea of saying, okay, I don't know what this is, but I know that it is not a monkey, it is not a leopard, it is not a civet, pretty much.
Thank you. Very great question. Thank you. I know there was another question.
Last question.
Maybe over here. We have very bright lights, so if you see me like squinting at you, it's because of that. Yes.
One thing for the person who asked the question earlier, the big thing in healthcare, I've been in healthcare for many years, it's the collaboration with healthcare facilities to make sure that this is helping them, not making the decision. So it's reducing their time to making decisions. So that's the best way if you're going to go into healthcare, is to work with them directly, and you also get their trust in the tool that you're building as well. So my question, you kind of said something about it. Again, it's mold detection that actually comes from my question, is the bias. So if you're going to take on the work of creating a model that detects anything, how can you ensure as part of your work you're always considering like those factors, so that you don't end up, you build a model that becomes successful, right? And it's used and picked up everywhere, but you realize it is going to cause some harm, right? Because either it, has its own bias. We're human, and we kind of can be introduced into the product as well. What are the things that we can actively do as startups or somebody building the solution to ensure that we are considering those?
Yeah, that is a fantastic question. I will say that is multi-approach. So from the data perspective, making sure that you have enough variety of data. Let's say for the mold detection app, let's say if you focus solely on people with a specific color of skin, right? And you don't have enough data that's representative across different colors of skin, then your model will perform worse for the data that you have less of. Right, so first having like a wide variety of data, making sure to test the output of your model extensively. So something that we didn't talk about here but can happen is that, and this is actually from the mole or healthcare system, is that usually when you take pictures of moles, you put a ruler next to it to keep track of the size of the mole, because this is important for diagnosis. But what can happen if you're not careful is that as you saw through all the layers of our model, it learns to detect the ruler. Why not, right? So you have to be mindful that when you're pre-processing your data and when you're testing it, you exclude those possibilities. Or something that can happen with animals is that maybe it's just, if let's say we're doing bats and bats only come out at night. I don't know if this is true, but let's say it is, then it might detect that all the photos from the traps are at night, and it's actually predicting if it's night or not night, not if it's a bat or some other animal. So you have to be really conscious on your data acquisition, pre-processing, and also in your testing that you exclude those possibilities. And I'm not sure, Leila, if you have something to add.
Yeah, the bias can be introduced one of two ways. So either through the data or through the modeling. If you're using quite simple models, you can, try to correct that. For example, I don't know, if to recognize a dog, you need a snout, but then you see a bulldog that does not have a snout. But you're certain as a person, and you build your model to recognize the snout, then the model is biased itself. The problem is that the more complex your model gets, the harder it is for you to introduce bias into the model and kind of change how it's thinking, right? Because I'm not understanding what it's saying. So I would focus more on the data, and not only what Vanessa said about, making sure that it's representative of what you're doing. So yes, if we're talking about different colors of skin having, how do I say this, balanced palette. But it's also, it can lie in much like more complex things. For example, let's say you're analyzing, like I'm just going to take that example again, but you're analyzing crime, and you see that geographically you get more areas that have more crime than others. Turns out that people there share specific characteristics, and then you could transfer to the fact that those are correlated. They might not be. Then you have to really do a data analysis on that to make sure to include only the features, what we call the features, the characteristics that you'd like, and to try and avoid including bias in there, right? So it can be quite simple, and then can get a lot more complicated. So you can never be sure that there's always going to be bias. but you can try and limit it.
Thank you.
Yeah, you're welcome. Great question. And we'll pause here, but thank you so much for your participation. I hope you enjoy your talk.
Thank you so much.
Thank you. Thank you. Thank you. That was super insightful. I hope you learned something and you're going to enjoy the sunny weekend just telling to all of your friends about Gen AI and computer vision, possibly. That would be very nice. A few closing words because I know I'm conscious of the time and the pizza needs. So first off, thank you for being here. So thank you so much for joining me today and joining us because it's a Friday night and it's something that is new and I'm very happy with the results. And please, I also ask you for a very big applause for all the speakers and the supporters that spent their time and their knowledge to teach us something. So please join me to say thank you to them. Thank you. And thank you to all of the sponsors too, of course. So without them, this couldn't be possible. Thank you, Google. A few announcements. So if you are willing to join Women TechMakers Brussels, there are the application open. You're going to receive the answer going through the application process during the summer. But you can still work with us. We can still work at the other events, other content. So if you're interested as a woman in tech, a woman that would like to join tech, reach out to me and apply. Feel free to join the chapter. So scan the QR code. Feel free. I'm going to move. Second announcement, you can be updated if you're into the cloud space by following GDG Cloud. They do a lot of events, very techy, if you're into that. And last one. So I opened GDG Brussels, which is for tech people, but also business people, but also women. So we do all of this. If you don't want to miss any news, you can also subscribe to this chapter of the GDG if you're already a developer in the tech space, into the business side. So this is really, I swear, the last slide. Thank you again. This was a first, but hopefully it's not going to be the last. And thank you again. Possibly we're going to see you at the next event. Bye. And there is the pizza. Now we can have it.